Okay, we're mixing an acid, ethanoic acid, with a carbonate, and we have to describe a change that would be seen in each test tube. Okay, firstly, let me say what sort of reaction this is. You've got ethanoic acid, which is of course an acid, and calcium carbonate, which is a carbonate. Okay? And whenever you mix an acid and a carbonate, you always get a salt, water, and carbon dioxide. Okay? That's a very important general reaction in chemistry that you need to remember. Acid plus carbonate goes to salt plus water plus CO2. It's a type of acid-base reaction. A carbonate is a base. An acid plus base goes to salt plus water, but acid plus carbonate, which is a base, goes to salt plus water plus CO2. Okay? Tattoo those on your brain right now. They're very important. Okay. I hesitated there because calcium carbonate is not an alkali, but it is a base. An alkali is a soluble base. Calcium carbonate is not soluble, which is why there are lumps of it and it hasn't dissolved in the acid solution. Okay, describe a change that would be seen in each test tube. Okay, the first test tube. You can say that the calcium carbonate decreases in size. Okay, don't say dissolves. Calcium carbonate is insoluble, it does not dissolve. So you can say that the calcium carbonate decreases in size. And the reason is it's reacting with the acid and being used up. Okay? 2 marks. You've described something and you've explained it. Okay? In the first test tube, you could say something else. You could also say you see fizzing or bubbles or effervescence. And the reason, you've described it, now you explain it for the 2nd mark. Total of 4 marks this question. Simply that carbon dioxide is being produced. Okay? Right. 2nd test tube. What's going to happen to lime water? Well, carbon dioxide is going through it, so it's going to turn cloudy. Okay, why? Right. If you chose this for the first test tube, you'll probably still get the marks if you just say because CO2 is produced here. But if for the first test tube you chose to talk about fizzing and you said that CO2 is produced, you could also say because, and it's a gas. Then you can't just repeat that here and expect to get 4 out of 4 marks. You have to go into more detail. And it's always sensible to go into more detail anyway, even if you didn't mention CO2 initially. So the reason the lime water turns cloudy is that the CO2 reacts with the calcium hydroxide. Lime water it's calcium hydroxide, basically, okay? So you would say that the CO2 reacts with the calcium hydroxide. And what does it make? The cloudiness comes, well, it's actually calcium carbonate. The same stuff that was over here is reformed in the lime water as the CO2 goes through it. And as we talked about, that's insoluble, so it's a solid, and that's why the lime water goes cloudy. to complete this reaction, it's CO2 plus calcium hydroxide makes calcium carbonate and water. If you're interested in the full reaction. Okay, so to get 4 marks, you have to mention something from test tube 1 and something from test tube 2. So it's either that or that for test tube 1 and that for test tube 2. Okay, next question. Complete the displayed structure of ethanoic acid. Right, well that's ethanoic acid, and they've given us this much of the structure. We have to complete the rest. Okay, Eth means 2 carbons. They've already given us 2 carbons, so don't need to add any more. Anoic acid. It's a carboxylic acid. And that's represented by COOH. So we've got to add the OO and the H to this C. So one of them is a double bond to an O. The other is a single bond to an O, which also has an H on it. Okay? That bit there is the COOH of that. And that's it. That's the full structure of ethanoic acid. You've just got to remember that carboxylic acids have that structure. Carbon double bonded to an oxygen, single bond to an oxygen, then a hydrogen on the other oxygen. Okay. Complete the sentence. Carboxylic acids react with alcohols in the presence of an acid catalyst to produce pleasant smelling compounds called esters. Again, you've just got to remember this stuff. To make esters, you react a carboxylic acid, such as that, with an alcohol, such as, let's have ethanol. Okay? So, I'm going to draw ethanol here. Right, there we are. That's an alcohol. Ethanol, eth, again 2 carbons, and the ol bit means OH. To make esters, you react a carboxylic acid, like ethanoic acid, with an alcohol, like ethanol, and you make an ester. So, let's go through it. Look at this. You can think of it like this. You have an H on the alcohol and an OH from the carboxylic acid. They're going to get together and make water. You see, we've got H2O there. And one of the side products of this reaction is water. Okay, and that's where it comes from. And what's left when you join this carbon straight to that oxygen, that's the ester. And this is how we should remember the reaction. So we get, I hope I've left myself enough space, I might have to fudge this a bit, or squeeze it in. Okay, this bit's all the same. Okay, so that bit is that bit. Now we've got a single bond straight to that oxygen. Okay? And now we just add on the rest here. Carbon, carbon, hydrogen, hydrogen, H, H. And that's it. That's an ester. Okay? Did you get that? Draw them next to each other like this. Remove that H and this OH, that becomes the water, and just do a single bond straight from this carbon with the double bonded to the oxygen, straight to that oxygen of the alcohol. And that is that bond there, and that is an ester. Okay? An ester has the functional group C, double bonded to an O, single bond to an oxygen, and then on either side, whatever. Okay, so that is what makes it an ester. The difference between a carboxylic acid and an ester is the carboxylic acid stops with hydrogen. But this, it's like a linking group, if you like. You can link different molecules together because there's not just a hydrogen there, like here. It keeps going. This chain could be much longer if you react it with a different molecule here. Okay, so you need to remember that to make esters, you react the carboxylic acid with an alcohol. And one thing I haven't mentioned yet, the final bit, is that you actually do it in the presence of an acid catalyst. Okay? If you're asked to name the acid catalyst, say it's sulfuric acid. Okay? I'll put that in brackets. It's a catalyst. Good. Right. Well, I sort of mentioned that in answering the question. Complete the sentence. Carboxylic acids react with alcohols in the presence of an acid catalyst to produce pleasant smelling compounds called esters. Right. Anion tests. This stuff up here. So, just have to complete the table. Right. Silver nitrate, okay, with a little bit of dilute nitric acid, that is the test for halide ions. So that means chloride, bromide, and iodide. Okay? Barium chloride with a little bit of dilute HCl, that's the test for sulphate ions. Again, you've just got to remember this stuff. I hated having to remember anion tests and flame tests. It's boring. I just wanted to grab the Bunsen burner and set fire to myself, but you've just got to remember it for the exam, I'm afraid. So, silver nitrate is tests for halide ions. So, can we see any halide ions up here? Yes, we can. Potassium chloride. That is a halide. It's a chlorine ion. Chloride is Cl minus. That's the chloride ion. Ion means the charged particle. It's got a charge of -1. So, something's going to happen here. And again, you've just got to remember it. Chloride makes a white precipitate. Okay? If it were bromide, it would make a cream precipitate. If it were iodide, it would make a yellow precipitate. Good. Okay, what about this one? Silver nitrate. Are there any halide ions here? Calcium, it's not halide. Nitrate, nothing halide-y about that. So, nothing happens, so it's no change. Okay, good. Barium chloride, the test for sulphate ions. Well, they made it a bit easy for us, assuming you've remembered your stuff. They've already told you that there's a white precipitate for the sulphate solution. So they've kind of, they've done it for you. Are there any sulfates in water? No. Are there any sulfates in potassium chloride? I can't see the word sulfate anywhere. So that's it. That's done. Correct. Right, flame tests. Again, in a mixture. Well, the reason is, if you have potassium and calcium ions mixed together and you do a flame test, the potassium ions will produce a lilac flame, but that will be mixed with the calcium ions producing a yellow-red flame. So you get whatever colour is produced by mixing a lilac and a yellow-red flame. So you can't really tell what's going on in there. Flame tests only work when you have the ion by itself, because you get a clear flame colour. So it's a 1-mark question. The short answer is, give one reason why flame tests will not show the presence of both of them. It's because the flame colours mix together. There we go. So, to summarise, remember that acids and carbonates always make salt and water and carbon dioxide. Acids and base make salt and water. And you've just got to remember your ion tests and your flame tests. Oh, and carboxylic acids reacted with alcohols in the presence of an acid make esters.